Good afternoon, everyone. I hope you are having a nice 3-day weekend so far. I am sending you this video for my even students because I gave them a worksheet on balancing reactions. Okay, this is the worksheet that you guys got last class. I'm sending you this video to do a practice problem with you guys because I got a lot of confusion last class on Friday. And I just want to make sure you understand it before you turn it in. So, this shows you how much I love you guys because I'm sitting here in my beach clothes, ready to go after I send this video. So that's how you know that I love you, is I'm making this video. And you better watch all of it. Okay, this is the hardest problem in the whole entire worksheet. So if you can get through this with me and you understand my steps, then you can finish any problem in the worksheet. You should be fine. Okay, so the front page has word equations and you have to write out the balance reaction. The second page gives you all of the formulas already in the balanced chemical ionic formulas, so you just have to balance it. Like when I say balance, I mean like the charges are already crossed, the formula's already written for you, and you just have to balance it. This one is a little bit more tricky because you have to write the correct reaction first with the formulas and the symbols, and then you balance it. So if you write the formula wrong, then your whole thing's wrong. So let's start. Okay, I'm gonna write out all of the ions and then we're gonna cross them. So magnesium, starting over here, magnesium is Mg. According to the periodic table, it has a 2+ charge. Okay, hydroxide is a polyatomic, it's OH minus. It's literally this simple. Ammonium is a polyatomic, NH4 plus. Phosphate, polyatomic, PO4, 3 minus. Okay, magnesium again, Mg, 2 plus. Phosphate again, PO4, 3 minus. When I told you polyatomics are going to stay, they're staying and they're coming back times 10. Okay, ammonia is not NH4 plus. No, that's ammonium. Ammonium is NH4 plus. Ammonia is actually a covalent compound, that's NH3. Which you wouldn't know unless I told you. And water, everyone knows what water is, H2O. Okay, so the only crossing charges that I really have to do for this problem are these three. Okay, and it's super simple. So I'll write it up here. Mg, 2 plus, OH minus. When I cross charges, all I want to do is rewrite the formulas and the letters exactly the way I see it. This 2 tells me I'm going to have 2 OHs. This 1 tells me I'm going to have 1 magnesium. My final answer is MgOH2. And I'm going to put that here. MgOH2. And the state of matter is aqueous. I'm putting aqueous. Okay, plus. Something here, so NH4 plus, and I have PO4, 3 minus. All I'm going to do here is rewrite the formulas exactly the way I see them without charges. So NH4, rewriting that. PO4, rewriting that. You see, if I rewrite it, I'm not changing it. This stays the same. All I'm changing is the number of things I have. Okay, so if I have 1 NH4, I'm going to have, a 1 charge for the NH4. I'm going to have 1 PO4. I don't touch it. There's no such thing as parentheses 1. It's redundant. You're not changing the 4 to a 1 because that's a polyatomic. If you change the 4 to a 1, it's a different thing. Okay, 3 NH4s. So I put parentheses 3 of them. There's my next formula. So I'll add that over here. Sorry if I'm going a little fast. Like I said, I'm literally going to the beach. And I'm in my bathing suit. So I'm ready to go. With the state of matter, aqueous. Okay, yields. Mg, 2 plus again, and PO4, 3 minus. Remember, plus, the cation's always first, the anion is always second. It's written like that in every single formula, every single name. I'm rewriting my formulas. I'm leaving out the charges, just rewriting this part. And I'm crossing it. So how many PO4s am I going to have? 2 of them. How many Mgs am I going to have? 3 of them. There's my next formula. Okay, so I'll put this here. And this is a solid. Okay, and I'm adding this to ammonia, which we said was NH3, and it's a gas, and water, which is H2O, which is a liquid most of the time. Okay, and there's my reaction. So this one's the hardest one. They're not all like this. They're all like, most of them are normal, and like you could solve them within like 3 steps, you know what I mean? So don't get discouraged. Okay, everything's written correctly, so I'm going to go ahead and split my reaction. And I'm going to write out all the elements that I see on the left. So I see magnesium, I see oxygen, I see hydrogen, I see nitrogen, and I see phosphorus. Right? That's all I see, right? Yes. Hey, some students asked me last class, can I just write NH4? Can I just write OH? Yes, you can, if that's the only thing you see on both sides. So OH does not show up on both sides, so I cannot do that. NH4 does. No, NH4 doesn't, so I can't do that. So no, you cannot do that. PO4 is the only thing that you could do, but again, there's other oxygens around. So like if this is not the only oxygen in the formula, like there's oxygens here and there's oxygens over here, then you can't do that because it's going to mess up the problem. If you don't know what I'm talking about, just ignore me, okay? Perfect. I'm going to copy and paste this exactly the way I see it on the other side because I want to compare them. Okay, now I'm just going to count how many elements I have on both sides. Magnesium. I only have one magnesium. I put one. Oxygen. Oxygen, I have one here, but it's parentheses 2. So I actually have 2 oxygens plus the 4 that are over here. So I have 6 oxygens. Hydrogen, same thing. I have 2 over here. So I have 2 over here, right, because of this. But I also have extras over here. So here I have 4. But remember, it's parentheses 3. So if I have 3 NH4s, okay, I'm writing out 3. This is 3 NH4s. I have 4, 4, 4. That's 12. I have actually 12 hydrogens. Okay, so be careful with the parentheses. I have a total of 12 hydrogens here because you could also just do 4 times 3. And that will give you the same thing. So just multiply. If it's in the parentheses and there's something outside of it, just distribute and multiply. Okay? So I have 2 hydrogens over here. I have 12 over here. That gives me a total of 14 hydrogens. Okay? Nitrogen, I have 1. But remember, it's 3 here. So it's 3 because of the parentheses. And then phosphorus, I only have 1. And those are all of my elements. We can do like a practice thing in class on how to count them because I feel like that's what's going to trip you guys up the most. Is that a lot of students just forget to add, like, oh, I have an oxygen here, like, they forget to add those, and then they put the wrong total, and then they balance wrong, and everything's a mess. Okay, magnesium, I have 3 over here. Oxygen, again, I have 4, but it's times 2, so 4 times 2 is 8. And then oxygen, I have only 1 over here, so I actually have 9 oxygens. For hydrogen, I have 3 over here, 2 over here, it gives me 5. And nitrogen, I have only 1. Over here, and then phosphorus I have 1, but again I have to distribute the 2, so I have 2 phosphorus. Okay, and those are all of my totals for all of these elements. Again, this is the hardest one, so don't be discouraged. They are not all like this. This is just the most difficult problem. When I looked at it last year with my students, it took us 10 straight minutes to balance it. So yeah, this is just a hard problem. And I don't make this worksheet, so don't complain about me or to me about this. I don't make the worksheets. I get them from other teachers. Thank you. Okay, so the way that I like to balance is, remember 2 things. Number 1, save oxygen and hydrogen for last. So do you see how I have a distribution of oxygens all over? Okay, you always want to save them for last. Same with hydrogen. I always have hydrogens distributed in every single molecule, almost every single molecule. So if you try to balance the hydrogens first, you're going to keep going in a circle, in a loop, and it's never going to end. So save them for last. Get the other ones balanced first. So I'm ignoring these 2 for a second, okay? Ignoring these 2. I like to start in order. So start from the top, go down, okay? So magnesium, I have 1 here and 3 here. I want to balance my magnesiums. Remember, we can never go down, but we can go up. I can multiply this by 3 to give me 3, so I have a matching 3 on the other side, but I can't divide this by 3 to give me 1, because can I have a fraction of an atom? No. Okay, so wherever I see the magnesium on this side, I will put a 3 coefficient in front. When I do that, I distribute the 3 to the magnesium, so now I have 3 magnesiums, but I also distribute it to the O and to the H. So it multiplies everything by 3. And you're not multiplying this by 3. You're not multiplying this by 3 because you remember I have oxygens here and hydrogens here. So that's wrong if you multiply this by 3 because then you're multiplying everything by 3. You get what I'm saying? You only multiply what's in this compound by 3. So here I have oxygen, but there's 2 of them, right? So 2 oxygens, what's 2 times 3? That gives me 6. So I have 6 plus the 4 that's here, so I actually have 10 now. Okay, let me say that again. I'm distributing this 3 to my magnesium, which I did. That's the only magnesium I have, so I have 3 of them. And also to the O. But I already have 2 O's in this compound. So it's 2 times 3, 6. I have 6 here, but I also have to take into account the oxygens on this side. Remember, we're splitting it by reactants versus products. So I'm counting all of the oxygens in the reactants. We said there's 6 here, there's also 4 over here. So 4 plus 6 gives me 10. Okay, for the hydrogens, I have 2 hydrogens. Okay, multiplying it by 3, I have 6 hydrogens. But remember, I also have hydrogens on this side. I have to add them. There are 12 hydrogens here. So 12 plus 6 gives me a total of 18. Perfect. Okay, next, remember we're skipping oxygen, hydrogen. See how we end up balancing them throughout the way. So just, save them for last. Nitrogen, I have 3 nitrogens here, and I have 1 nitrogen here. So I'm going to make this nitrogen become a 3 by putting a 3 coefficient in front of wherever nitrogen is. I can't only apply that 3 to the nitrogen. It's like if you do math. If I distribute, right? If I distribute to the x, I must distribute to the 4. It's just basic algebra. So if I distribute to my nitrogen, I have to distribute to my hydrogen. Okay, so if I do something to one thing in the compound, I have to do it to the other thing. So if I add 3 in front of the nitrogen, I now have 3 nitrogens. But I also have, what's 3 times 3? 9 hydrogens plus 2 over here gives me now 11 hydrogens. Okay? Perfect. Hey, going back to my order. Now my nitrogens are balanced. Now I have to balance my phosphorus, and we'll see where we're at from there. Okay, so I have 1 and I have 2. I want to make this guy over here on the left 2, so I can balance them, meaning I put a 2 in front of the compound that it's in. Phosphorus is in this very big compound, so I have to put a 2 in front of the whole thing. I cannot just multiply P by 2 and call it a day. That's wrong. It's just like distributing. You have to do it to everyone. So if I multiply P by 2, which I did, I change it to 2. Now let's times my nitrogen by 2. But remember, I have 3 nitrogens already. What is 3 times 2? 6. So my nitrogens now change to 6. Okay, for my hydrogens, I already have 12 hydrogens in this compound. 4 times 3 is 12. Multiplying that by 2 gives me 24. But now, again, I have hydrogens over here also. So I have to add those guys up together. So I have 2 hydrogens times 3, that's 6. So 6 plus 24 gives me actually have a total of 30 hydrogens. Okay? I'm trying to erase the mess as I go. All you have to really remember is that if you do something on one side to one atom in the formula, you have to do it to everyone else. And you also have to keep an eye out if I have multiple hydrogens within the formula, or multiple oxygens, or multiple magnesiums. I have to add them all together on that one side, whether it be reactants or whether it be products. Okay? So good. We just did 2 times the N. We did the 2 times the H. Now I have to do 2 times the P, which we already did actually. 2 times O. That's 4 O's times 2 is 8. So I have 8 oxygens here, plus the 6 that I already have, right? Plus the 6 that I already have, that gives me 14. Okay? That's what I have so far. Now, I look at my other side, and now I have to figure out how the hell I'm going to balance this, right? How am I going to balance this? So, like I said, save who for last? Save oxygen and hydrogen for last. So, who can I fix here that's not oxygen and hydrogen? Well, my magnesiums are balanced. Oxygen and hydrogen are not balanced. We're saving them for last. My nitrogens are not balanced, and my phosphorus is balanced. So I'm going to balance my nitrogens first, because again, I am saving O and H for last because they continue to change. So I want to make this the same thing. So look at this. How can I get this number to be 6? I have to multiply it by 2. So wherever I see the N, I times it by 2. But hold on a second. N already has a number in front. I need this to have 6 nitrogens. How can I make this 6 nitrogens? I remove the coefficient. Yes, you can do that. And put it 6 now. 6 times N gives me the 6 nitrogens that I need. 6 times the 3 hydrogens. That gives me 18 hydrogens. Plus the 2 that are over here, which gives me a total of 20. So now I have 20 hydrogens and 6 nitrogens. Everything is balanced except for my hydrogens and my oxygens. So then I'm going to go from there. Okay, it's all, which is convenient for us because my hydrogens and my oxygens are all in one compound. So if I balance them, it's not going to affect anyone else, which is what we want. So remember, I need to figure out a way, what number can I put here that if I add up all my hydrogens together, it gives me, what's on the other side? 30. Okay, because I want it to be 30. I can't go down, but I can go up. So I need this to be 30. So how many hydrogens do I need to make 30? So at this point, I just play around with numbers. So let's put a random number in front of H2O, 2. Okay, what's 2 times 2? 4. What's 6 times 3? 18. What does this give me? 22. How many do I need? I need 30. So I need a bigger number than that. I'm not going to put 2 in front. Okay, let's try 4. If I put a 4 in front of the H2O. Okay, well, what's 4 times 2? 4 times the 2 hydrogen, that's 8 hydrogens. Plus, well, what's 6 times 3? 18. 18 plus 8 gives me what? 26? That's still not enough, right? It's still not enough. So then I'm going to erase it again, try another number. Let's put a different number. I'll go even higher. Let's go to 6. 6 times 2 gives me 12. Plus, what's 6 times 3? 18. This gives me 30. So if I put a 6 in front of the H, this makes my H's become 30, which it is on this side, so I balanced it. So this guy is good. This guy is good. This guy is good. This guy is good. The only guy who's missing is oxygen, which is good because I added a 6 in front of the H2O. So remember, if I add a 6 or if I add any type of coefficient in front of this compound, it applies to both. It applies to both. So I have to do 6 times the H, but I also do 6 times the O. So I have 6 O's, not 60. 6 oxygens. So remember, we already did the hydrogens. I don't care about that. 6 oxygens, but I also have how many here? 8. What's 8 plus 6? 14. So now this becomes 14. And now on the other side, do I have 14? Yes, I do. So now all of my whole reactions balance with these are my coefficients. 3, 2. If there's no number, it's a 1, 6, 6. Okay, and that's how you balance the reaction. So again, this is the hardest one in the whole worksheet. You're never going to get something this difficult on a test or quiz. This is just kind of like to test your brain, rack your brain a little bit, practice. If you can get through this, you can get through anything, right? Any type of problem I give you, if you get through this, you can get through anything. So hopefully this helps. I would practice trying to count up, all of the atoms in a formula. Don't let the parentheses confuse you. This is like distribution. Okay, if there's 4 oxygens, but it's times 2, so it's 8 oxygens. There's 1 phosphorus here, but it's times 2, so it's 2 phosphorus. And just get practice on counting that. Okay, if this is too fast, I'm sorry. I really want to go to the beach. Just slow down the video and you can watch it like that. But if you have any questions, just let me know. Bye.